Okay, next will be perpetuities. What is perpetuity? Perpetuity is an annuity, annuity with annual payment of 1, which continues forever. Well, it doesn't have to be annual payment of 1 actually. It is an annuity immediate with annual payments or regular payments with regular payment which continues forever. So we can also think of it as an A angle infinity. So the payment will go on forever. So the n will approach infinity. So if we want to find the present value is equals to the present value of A angle n when n approach infinity. So this one will approach 0. So you will just end up having 1 over I. So this is the present value for our perpetuity with level payment of 1 ringgit. Usually perpetuity we don't find accumulated value, right? Because the one that I showed you is perpetuity immediate, but if you want to do the same for perpetuity due, you want to find the present value for perpetuity due. It is basically you write down the formula for annuity due. So this is the formula for annuity due, right? Formula for A double dot angle n. So it's this is the formula. So you find what is the formula when n approach infinity. So the present value will be 1 over d. So the difference between A double dot angle infinity and A angle infinity is the first payment. Do you see that? So for A perpetuity immediate, the payment is like as follows: 1 1 1 1 1 1 until infinity. But present value for annuity due is 1 1 1 1 1 1 1 until infinity. So the only difference is this part, right? So perpetuity due minus perpetuity immediate is equals to 1. The difference is 1. So that's why we get this relationship 1 over d. So this is 1 over d minus 1 over I is equals to 1. So in the first chapter last week, we see a few relationship between d and I, and one of the relationship between d and I is this: 1 over d minus 1 over I equals to 1. So this is how we get it. If we understand the perpetuity immediate and perpetuity due, then we can understand this relationship. But to be honest, I rarely use this relationship between I and D. Okay, so exercise if we have block payment of perpetuity. So this is the perpetuity between 1 to 10. Our block is $100. Between 11 to 20, our block is 150. But 21 to infinity, the block is 200. So it goes 200 until infinity. So again, if we want to do block payment, remember we need to find from the furthest point and then go towards the evaluation date. So since we are evaluating present value, our evaluation date is 0 times 0. So we start at the very end. So the very end, the last block will be the 200. Okay, the third block. The last block is the third block. The third block is $200 for infinity. So you do 200 over I. And then the next block is 150. So the difference between 200 and 150 is you minus 50. And then you are doing this just for the blocks that is before this one, kan? So A 20. And then the first block is the difference is also 50. So you minus another 50 for the first block only, which is A 10. Okay. Next. Try to build relationship between a perpetuity term annuity, and deferred perpetuity. Okay, a perpetuity, what does it consist of? Perpetuity is one payment of 1 until infinity, right? This is T. So the payment is 1, 1, 1, 1, 1 until infinity. So let's say we have an N here. This is N. So if we do A, if the perpetuity is equals to term annuity, A angle N. So A angle N we will cover until this payment. And then we have this part. So this part. So A angle N plus what? What is this part? This part is technically in a perpetuity because this perpetuity lasts forever. So it is a perpetuity, but it is a deferred perpetuity because this perpetuity is evaluated at time N. So it is evaluated at time N. So this is A, V, N. So the perpetuity so it is the perpetuity, but you need to discount it because now it's evaluated at time N. You need to evaluate at time 0, so you need to discount it for N years. So this is also equals to a deferred annuity, right? Deferred annuity N bar A angle infinity. So it's the same thing. You can write it like this, or you can also write it like this. Okay. So this is the relationship between perpetuity, annuity, term annuity, and perpetuity, term annuity, and deferred perpetuity. Okay. Next, relationship between A angle N and A angle 2N. Okay, as I said just now, when there's 4 unknown, there's 4 variable for an annuity. If you know 3 information, then you can solve for the 4th. But sometimes in IFOA or SOA questions, there are questions where they don't let you know 2 variable. So two informations are not known, but they give you information of 2 different annuity. One, they give information for A angle N, and the other one they give information for A angle 2N. But for each of this annuity, you just know 2 information only. So maybe you know the I and the payment, maybe. So you don't know the N and the present value. And this one also same. You give I and the payment, but it doesn't give you the N and the present value amount. Okay, so because of that, you need to know a special relationship to solve this problem. So for example, you have deposits of $50 are made at the end of N years. Oh, okay, this question is not complete. So the present value of the deposit of 50 made at the end of N years is this. Present value of deposit of 150 made at the end of 2N years is this. At the end of every, okay? Okay, so basically if you draw, you will have like over N years, the deposit is 50 each year. And then the next one is for 2N. Every year you have 150. Okay, so you have 2 information, the payment and also the present value, but you don't know the I and the N. So then how do you solve this? Okay, solve this, you need to leverage on the relationship between A angle N and A angle 2N. So A angle 2N over A angle N is equals to, if you remember the relationship, the formula is 1 minus V to the power of 2N, right, over I. And then for this one, for this A angle N is 1 minus V to the power N over I. So because both is over I, we cut, and then we are left with just this lah, 1 minus V to the power of 2N over 1 minus V to the power of N. Okay, so then is equals to, you can simplify this. You can rewrite this numerator to be 1 minus Vn 1 plus Vn. You see that? Because you can also rewrite this as 1 over 2 minus Vn over 2. Betul tak? Okay, so if you rewrite it, you can rewrite it like this, over 1 minus Vn. So if you can see this, you can cut this. So the ratio between A to N and A angle to N and A angle N is equals to, the ratio is equals to 1 plus V to the power of N. Okay, so now we have this relationship. You are now one step closer. So 1 plus V to the power of N is equals to this time over this. So we know this information. A angle to N is basically, A angle to N is 1472.72 divided by 150. And then A or angle N is 335.504 divided by 50. Okay, so 1 plus V to the power of N is equals to 1.463. And so we know V to the power of N is 0.463. Okay. Okay, so now you know 50 times A angle N is equals to 335.5404. 50 and A angle N is 1 minus V to the power of N over I. So you know V to the power of N is equals to 0.463. So 1 minus 0.463 over I is equals to 6.7. So I is equals to 0.0895 or 8.9%. Okay, so basically remember, sometimes there will be cases where you need to leverage on this relationship between A to N, A angle to N and A angle N. Alright, moving on. Varying interest rate. Okay, I just want to highlight to you that there are two separate type of varying interest rate that you can come across. First, let's read this. An annual deposit of 100 is made at the beginning of each year for 10 years. Find the accumulated value at the end of the 10 years if the effective interest rate is 8% for the first 6 years and 7% for the last 6 years. Okay, so last 4 years. So you have 10 years total. For the first 6 years, the I is 7%. And the last 4 years, the I is, sorry, this one is 8%, this one is 7%. I is 7%. Okay, so for this case, you see the annuity is a 10-year annuity, but the interest change in between before it complete the 10 payments, there's an interest change. So you need to evaluate the two blocks separately. But this one is not block payments because the amount is all level from 0 to 10. The amount is level, but the interest change. So then you need to write as follows. You need to specify the interest rate. So when before this we never write the percentage, the interest rate, because it have always been level, but when it's not level, you need to make sure you write S angle N and what is the I that is related to that specific annuity. So let's see. Now we will split the annuity into two parts for the first 6 years and the next 4 years. So the first 6 years it will be 100 S angle 6 because we want to find accumulated value, and this is evaluated at time with interest rate of 8%. But this is evaluated at time 6, you know. So this is evaluated at time 6, but we want to see, we want to find the accumulated value at time 10. So we need to accumulate a little bit more, another 4 years. But when we accumulate another 4 years, it's not with 8%. Because you remember, the interest rate is 7% for the next 4 years. So you need to accumulate with 7%. Okay? So 1.07 to the power 4. Okay, plus the remaining annuity, 4 years remaining. So 100 times S4 evaluated at time 7, at interest 7%. Okay. Moving on. Next type of varying interest rate is same criteria. An annual deposit of 100 is made at the beginning of each year for 10 years. Oh, one thing you need to be careful. This one is the beginning of each year, okay? So I have to actually write it as follows. Okay. Why don't we just change this, okay? Change this to end of year. Change it to end. So this example is suitable for end of year. Okay, it's okay. Okay. Oh, okay. Alright. One thing you need to be careful, okay? This question is asking the annuity is paid in the beginning of each year, okay? So the answer should actually be with double dots. I was wrong. So just add the double dots. Okay. Next scenario, an annual deposit of 100 is made at the beginning of each year for 10 years, same as before. Find accumulated value at end of 10 years if the first 6 deposits are invested at 8% effective and the last 4 deposits are invested at 7% effective. So the deposits are invested So the deposits are invested in 2 separate funds. Okay, the first 6 deposit is invested in fund X, let's say, and this fund is actually earning 8% effective, and the last 4 deposits are invested in another fund Y, and that deposit are invested at 7% effective. So meaning when this fund give 8%, no matter when the time is, so between time 0 to time 10, the whole time it is giving effective interest rate of 8%, and this fund the whole time between 0 to 10 it will give an annual effective of 7%. So they are in 2 separate funds with 2 separate interest structure. It's different with this one. This one is all payments are in one fund, but that one specific fund changes their interest rate. Okay, so I hope you can differentiate these two. So for this one, you will do again put the double dot, so it will be 100 S double dot angle 6, and then you will evaluate it at time 8%. Sorry, you will evaluate it with interest rate of 8%, and this is evaluated at time 6, but we want to find AV10, so we need to accumulate to time 10, but the accumulation will be based on fund X's interest rate. So the fund X interest rate is 8%, not 7%. And then the last 4 deposit is invested at time 7, 8, 9, 10. So it will be evaluated at time 10, so we don't need to accumulate it further because it's already evaluated at time 10. Okay, I really hope you can see the difference between these two cases. Alright, this is the summary. Alright, that's all. Bye.